guys, this is my hopper. Today I'll be explaining a little behind its physics just so you can understand what I'm doing here. We'll start off with our known values. This is what we use for our calculations. So we start off with Hooke's law to find the constant of elasticity. Hooke's law states that force is equal to the constant divided by the displacement. I'll show you guys how to find the displacement after this. But we can rearrange this equation to have the constant equal to the mass times the acceleration due to gravity divided by the displacement. Using these values, we find that the constant of elasticity is equal to 0.88 newtons. So this is what I did to find the displacement for my constant of elasticity. I simply tied a mass to the rubber band and measured the distance. As you can see on mine I have a watch, but I actually used a mass of about 20 grams for my calculations. After finding our constant of elasticity, we can calculate the time period. This is simply the time it takes for one rotation from side to side. The time period is equal to 2 pi times the square root of the mass divided by the constant of elasticity. Theoretically, I found this value to be 0.08 seconds. For my hopper, that was actually 0.19 seconds. As you can see, I switched out the 2 pi for my theoretical and hopper values. With our time period, we can calculate our angular velocity. This is how fast the fan goes from side to side. Angular velocity is equal to the change in theta with respect to time. Theoretically, I found this to be 6.54 radians per second. For my hopper, that was actually 6.43 radians per second. So the last part of my physics is finding what distance my hopper would have traveled. We find this using harmonic motion. One of the formulas states that displacement is equal to the amplitude times sine of the angular velocity times time. Plugging in our numbers, we actually find this to be 0.07 meters. Theoretically, for my hopper, that would have been 0.12 meters.